Thank you all for joining today. This is the Purkeys. Can solar be a bright spot for your fleet? That's, as things have changed, solar is becoming more and more common, more and more used in fleets for many different applications, whether it's lift gates, cab power, reefer, to offset parasitic loads, lots of different things. So today, Cody Johnson, our product development engineer, and myself, Larry Rambeaux, we're just going to kind of go over a bunch of different, kind of highlights on solar. What is solar? What can it do? What can it not do? A little bit on testing, applications. So just a scope here, kind of a quick outline of what we're going to cover. One is, why is solar? We'll go into that more, but applications, key questions. We kind of have a little bit of a myth section, how to test it, and we'll go over the resources and some FAQs. If you have any questions as we go over this, please feel free to type them in if you're on the live one. We will answer them as we can, and definitely take some time at the end of this to go over them. Turn it over to Cody now.
So why solar? We get a lot of interest from a lot of different fleets and applications and configurations of systems about solar. It's a bit of a buzzword nowadays. But the great thing about solar is that it charges your batteries without an alternator. There are no moving parts. It sits on top of your system and charges your batteries when the sun is out. If you park your trailer for a day, it's going to charge the whole time or while it's running as well. And so there are applications for this on both trailers and tractors. Supports charging liftgate batteries or reefer batteries or starter batteries in tractors to make sure that if they're sitting for long periods of time, you make sure that they're always going to start. So it's a great passive power source, which we can get a lot of value out of.
And the nice thing about solar too is once you pay for it up front, there's really no cost afterwards. There's no real maintenance to it. Obviously not very good if it's on top of a piece of equipment and someone tries to haul a tree or a bridge, but other than that, they're very low maintenance and constantly pay for themselves. Talk a little bit about applications. Whether it's a truck, trailer, kind of go over these as a whole and then individually, but there's so many things that are being powered off a battery anymore. Whether it's a lift gate, whether it's air curtains in trailers, tracking systems, electric air conditioning in trucks. And one of the biggest things that COVID's really shown a lot of fleets and a lot of different applications is equipment sits at times. And solar can be a wonderful solution that if any equipment sits, no matter what it is, if it's got a battery on it, there are parasitic draws on those vehicles, and they are going to pull those batteries down. So solar is a wonderful way that we can offset those parasitic draws and make sure vehicles are ready to be used. Applications for sleeper. One of the biggest things that we see on all this across the board, no matter what, is increasing battery life. The higher state of charge we can keep those batteries and limit, discharging, the better, environment those batteries have, and the longer they're going to live. One thing about batteries is the harder you cycle them, the shorter life they're going to have. So if we can keep them up close to 100%, it's going to have wonders for it. Plus, we've seen some benefits of basically conditioning batteries by being able to get them at a good high state of charge, even when they're parked. Driver comfort. More and more fleets are using electric APUs, so this can help make sure those batteries get charged again when they're parked. We still have parasitics, but if they are using those EPUs, we can increase the time that truck can be powered off those batteries before having to be restarted. The other thing too is any time you go to a fleet, there is vehicles that are parked. This helps make sure they are, always at 100%, and so when they are needed, they're ready to go. Not have to bring a truck in the shop and charge batteries or change batteries simply because they've been discharged because of loads left on. Another applications, trailer. This is one of our biggest ones. A lot of you that know Purkeys know we are the pioneers and the solution provider for liftgate charging. Just like the truck side, we can increase battery life by keeping those batteries at a higher state of charge. Equipment utilization, trailers get parked. Depending upon the operation of the vehicle, some fleets are parked all weekend. With solar, we can guarantee those things are always charge ready to go the first of the week. The other thing, too, is with limitations of charging or engines running during the day. This can be a great complement to other liftgate charging to put more energy in those batteries. That's one thing. Nobody ever complains that we put too much energy in batteries. And see, if you look at trailers too, people look at those liftgate batteries as a unlimited power supply. So, well, we'll connect this to them. We'll put those on. Again, electric door, the air curtains, tracking systems. There's so many things people are trying to pull off those liftgate batteries that this can give you another solution to put more energy back into them. Straight trucks. More and more straight trucks are being used for that, kind of final mile delivery service. More and more fleets that, have always ran, 28 footers or 53 footers are getting into straight trucks now because of that final mile, delivery type situation. And where we're seeing some real benefits for these is, again, the parasitics on new trucks are just outrageous. And when that cab and chassis gets built and it gets delivered to a box company, it may sit there for weeks or maybe even months before they're in line for getting their box built. We've seen tons of these that have had dead batteries before they even get in there to have the box put on. So this can do some major things by putting the panel on the cab roof to make sure those batteries stay charged before it even gets the box put on. And one of the last applications is reefer. That reefers have lots and lots of parasitic draws on them anymore. It used to be when the reefer wasn't running, they just sat there and they were, pretty tame draws on them. Now with a lot of the new food safety rules, they've got temperature monitoring on them, they've got tracking on them. Some of these can have some very substantial parasitic loads, and this does wonders. And again, in today's time, that a lot of fleets not only are hauling refrigerated product, but if there's no lettuce to be hauled or whatever, they may be hauling paper towels and that reefer doesn't start. And nobody wants to run an engine that they don't have to, so this can help guarantee that that reefer battery stays charged as well. We've got our first poll question for you for today. And this is just kind of to know our fleets and customers and attendees on this better is, does your fleet currently use solar or any of the following? For these poll questions, if you would, just check mark the box, and you can check multiple boxes on this, but you have to check mark the box and then hit submit. But, does your fleet currently use solar on trucks, reefers, liftgate batteries, straight trucks? We'll give you, a few seconds there to click and submit. Then we'll see the results, just kind of see what kind of solar usage is out there already. All righty. And we've got some of everything out there. Half of y'all, a quarter of you use it on trucks, but half of the people attending today use it on reefers, liftgates, and straight trucks. So obviously, solar is becoming more and more popular. Obviously, it's a green solution that helps with everybody for the public image, and it can do wonders for the battery life. So I'm going to turn this one back over now to Cody.
So any fleet that's considering using solar has a few questions they need to ask themselves. What kind of controller do I need for my system? What type of panel does the system use, whether it's flexible or rigid, which one's best for you? And then how much power do you need? Larry mentioned earlier that people often assume that the batteries on their systems are unlimited sources of power, but it's always power in and power out. And so we're going to go through a few of those details here. So the first thing to ask is, what controller do I have or do I need? So the two types of controllers for solar applications are MPPT and PWM. MPPT stands for maximum power point tracking, and PWM stands for pulse width modulation. The main difference between these is efficiency. The MPPT is more efficient, but all they really do is they have different methods of changing or conditioning the power that it gets from the solar panels so that it can effectively and efficiently move that power to its load. In this case, in most cases, it's a battery. So MPPTs, because they're more efficient, are slightly more expensive. They're generally needed whenever you have a higher set of a higher power or higher number of panels in your configuration. And then for pulse width modulation, if you have a small panel, 20 watts, 50 watts, something like that, that generally can use a PWM. You're not trying to get every ounce of energy from one place to the other. You just kind of need it to get there. So again, MPPT, generally your larger and more sophisticated applications, PWM, quick and dirty, cheap and easy. And so here you can see a little bit more detail. Maximum power point tracker, without getting into too much detail, tries and takes all of your current and voltage in and tries to hit that sweet spot for what the output is. The PWM just kind of throttles it back and forth. If you know anything about AM and FM radios, it's somewhat the same concept. It pulses at different rates in order to move that power from one place to the other. So panel type, you have monocrystalline and polycrystalline. Polycrystalline are those bright blue cells that you may have seen, especially early in the solar world. Polycrystalline is exactly what it sounds like. It's many pieces of silicon that are put together and smashed into a composite so that you can make a cell. Well, monocrystalline is more efficient and more flexible because it's made out of a single piece of silicon. They grow these big silicon wafers and cells just like they do for computer chips, and then slice it really thinly. And so as a result, the electricity doesn't have to travel across as many boundaries within the material, and so much more efficient. But the great thing about this newest generation of solar panels in monocrystalline applications is that you get these flexible panels. So you can finally contour to the fin of your tractor, or your installation gets better because it's lighter, because it doesn't have to be supported by a glass and metal fixture to go out on a trailer or a straight truck. And then lastly, how much power do you need? This varies from application to application. It depends on whether or not you're using a liftgate and what kind of liftgate you're using, how many batteries you have, what your duty cycle looks like. So how many shifts does your tractor run? How many lifts do you do on a regular basis? Do you run lights on this trailer? Are they LEDs or are they incandescents? There are a lot of things to consider. And most of the time, in a few minutes on the back of a napkin, you can calculate how much power you need, but it's really important to know how much power you need and how much you can get out of a panel. Your location also matters. So geography is part of it. We're going to get into that a little bit later. But trying to figure out what you're pulling out of it tells you how much you need to put into it. An interesting thing to note is that whenever you see a panel that's rated for 100 watts, you're not going to get 100 watts out of it. You're generally only going to get about 75% of its rated power out of it. If you look at the fine print on those panels, it says, STA. It's a ideal setting where they test everything at a perfect irradiance and temperature level, which is unlikely to happen in the real world. So keep that in mind whenever you're sizing your system. So we put some example calculations here for liftgate applications. We make an assumption that you're going to, for a rail lift, those big rail lifts on the back of trailers, that they pull about 250 amps for about 18 seconds, which translates to about 1¼ amp hours getting pulled out of a battery every time you do a lift. For a tuck under lift, it's only about 180 amps, so that pulls out just under 1 amp hour. And you can see in the picture that we have there, so our offering comes in 110, 220, or 330 watt 1, 2, and 3 panel configurations. And this gives you an idea of how many lifts you're going to get out of the power that those panels will generate. And this will be part of the resources for afterwards. So you can use this as a rule of thumb to determine what your needs are based on how much power you pull out of them.
And that's, just a snapshot. That there's lots of other factors like you talked about before. Is, what part of the country are you in? When do you operate? So again, that's a quick snapshot rule of thumb. But before we'd ever tell anybody, yeah, you need to buy a 2-panel system or whatever, we want to take time to talk to you and make sure we understand your fleet and how it operates and where you're located. There are solar maps that you can look at that, there's a huge difference if you're a fleet operating in Phoenix versus a fleet operating in Portland or, North Dakota. There is a difference in all that. So, again, rule of thumb, but that's what our job is. And that's why, me as a sales application engineer and Cody as a product development engineer, that's why we're here to kind of go through it all to make sure we give somebody the right solution.
So the environmental factors that we mentioned, this is a decent graph to give you an idea of what range of power output you're going to get throughout the year based on different weather conditions. So you'll notice, obviously, in the in sunny parts of the summer, and particularly at the middle of the day, is whenever you're going to get the largest amount of irradiance from the sun because it's directly overhead. You're not going to have shadows cast and all of that. But there, like Larry said, there are solar maps that you can look at that are provided by NOAA that you can look up and determine what's reasonable for your part of the world.
All righty. And Cody covered some of these already as he was talking, but there's a lot of myths about solar. One of the questions is, and I've seen it myself many times doing installs at fleets, is you're in the shop even at night, got the shop lights on. It says, does solar work under fluorescent lights? What's your definition of work? Does it come on and have some output? Yes. Are you ever going to charge batteries with that output? No. But it does come on. But it's a different type of light that's coming from fluorescent bulbs or, sodium halide or mercury halide, any of the, shop lights. They are going to produce light and it is going to produce some power. But is it really charging batteries with that type of light and that amount of light? No. So that's one of those things that, we try to separate, some of the myths and realities. There's times that it quote unquote works. And, again, what is your definition of work? So yes, they do work under fluorescent, but it's very limited output because, again, it's a different type of light and direction and everything. The solar work at night, again, goes back to what's your definition of work. Yes, there is light. That sunlight is reflected off the moon or street lights, parking lot lights. Yes, it does come on. And when we talk about the testing, we'll show you the indicator lights on our controller. But yes, it is on. It is doing something, but again, it's a very, very low output. So if someone tells you theirs works at night, you got to take that with a grain of salt. But these are solar panels, not lunar panels. So you got to take it with a grain of salt what they can and can't do. Solar works well, not at all in cloudy days. Again, difference of it. You are going to get a lot of light, and you are going to get some output. Is it ever going to be the same? No. But it is going to have output, and that's where we look at that an entire day. And we've done data recorders for a lot of fleets, and we can look at that is over the course of the day, whether it's 6 o'clock in the morning where you're barely getting light and it's at a very steep angle or very low angle, so a lot of the light's going to bounce off versus a more direct light. So you look at that light harvest time over an entire day, not just okay, at noon it puts out 80 watts per panel or whatever. Because yes, at 6 in the morning may only be putting out 10 watts. But again, they do work on sunny days and cloudy days, so you're always going to be harvesting some, but it is going to vary based on those times of day and available light. A little bit about testing. We mentioned this before. This is the side view of our controller for the Solar Bolt product. If you hook this up, you will get the yellow LED will be on, and the green LED will be on. If it is charging, that green light will be flashing. Again, even in a shop at night under shop lights, will that green light be on and flash? Yes, it will. If you put a clip-on ammeter over it at that time, very, very little output, but yes, it is putting out some. But it does tell you at a glance, is the system working? For actual testing, you can't beat the old good old-fashioned clip-on ammeter and voltmeter. This was a truck I just did the other day, but put a clip-on ammeter around the output coming from the controller to the batteries. This one was actually a truck, but you could see under full light outside, it was a single panel. It was putting out a little over 7 amps. We looked at the voltage, and it was climbing at this snapshot where I took this picture. We were at 13.12, but that is a truck that's parked doing nothing, that no matter what, when someone needs that tractor, it is ready to go. Those batteries are in a very good state of charge. And again, that's going to have some big impacts on the life of those batteries by staying at a good state of charge and keeping them conditioned versus, a typical parked truck that sits, half the time in a very discharged condition. One is kind of the hope method. You hope the driver's going to hop in the truck and drive long enough to get the batteries recharged and everything's good. Or at least hope he's far enough away that he's someone else's road call, not yours. A couple things you do have to be careful when you are doing this test, though, is, what is the state of charge of those batteries? If the batteries are already, 100%, solar ain't going to do much. It's going to kind of, sit there and float boat because they're charged. Same with an alternator on a truck. If the batteries are charged, the alternator is really kind of a very expensive idler pulley at that time. But if those batteries are discharged, obviously the solar is going to put out more. Again, depends on, ambient light that it has. If it's early in the morning or, very overcast day, it's going to be less output. But one thing I always tell people, if the batteries are in a good state of charge, crank it a couple times, shut it off so you pull those batteries down some, or turn the headlights on. Something to pull those batteries down so you can get a fair test. And again, make sure where you are. You obviously cannot test a solar panel at night for output, and you can't test it inside the shop. So, take it outside where it's a nice, clear day.
So we're going to have our second poll question of the webinar now. So just as before, if you will select your answers here and then click the submit button at the bottom right, when is the best time to test a solar charging system? See if you've been listening to what Larry's been saying. So on a sunny day, while the unit is in the shop, or on a cloudy day. I'll give you another 20 seconds.
This was some fresh information, so.
All right. Good job, everyone. Good job. So yeah, on a sunny day is the best time to test. It's whenever you're going to get the largest response out of your solar panel. So as Celia mentioned before, at the bottom of your screen in the resources widget, you can get all of the resources that we have for this webinar. You can get this presentation as well as some links. And we posted a few frequently asked questions here. We've covered many of these already, but just for emphasis. So how do I know my system is working? You measure the current output on the panels to the controller at your battery with a handheld ammeter. Constantly changing current is common. It's not going to be constant for a number of different reasons. Those controllers modify its output based on both its input and its output. So it'll move around a bit, and that's okay. That's normal. Where should I mount the panels and the controller? The roof, obviously. But whenever you're mounting it on a trailer, we generally recommend mounting it at the back of the trailer. Since trailers have a tendency to have damage at the front of the trailer, we don't want to have to fix the panels as well as the body of the trailer. Are the panels going to come off or delaminate? This is a question that we get asked fairly frequently regarding the durability of these panels. And while anything is possible, it's not very likely that the panels will come off. Our panels ship with grommets that can be riveted down to the application, as well as a very, very strong adhesive on the back of them that keeps them stuck down. Regarding delamination, I've never heard of any of our panels getting delaminated. They're made with very, very, very strong polymers that are UV and weather resistant to a very high degree. So it's not a problem we've encountered. And can I power my pallet jack? Some of you may be familiar with our tap system, and the answer is yes, you can power a pallet jack, but depending on what type of pallet jack you have, you may have to have an inverter to convert that DC power of the panel into the AC power that some pallet jacks require in order to charge. And generally, you have a battery somewhere in there to make sure that you're not solely relying on whether or not it's sunny to give it power. And I want to take this opportunity to mention a new set of panels that we'll be offering very soon. So we have a new and improved solar dash that some of you may be familiar with, which is our 20-watt panel, which is designed specifically to be mounted on the dash of a truck so that you keep the starter battery maintained. But we've also heard the need and listened to the need of a slightly more powerful version. So we've gotten a 50-watt panel that we're going to call the Solar Dart. So we'll have the dash, the dart, and the bolt all together as our total solar offering. One of the things to note about these new solar kits is that they are PWM controllers because they're in that smaller solar panel range. They're 24 volt or 24 volt or 12 volt system compatible. That it adjusts automatically, so there's no configuration needed. You just plug it up to one or the other, and the panel and the controller does the work. They come with alligator clips, a DC plug to go into the truck if you have one that is a direct connection into the battery. Not all of them are. Some of them are only active whenever the ignition is on, so it's something to check on your tractor or truck configuration. There are also ring terminal attachments and a cable extension to make installation as easy as possible.
Yeah, the big reason we made the dash was sell trucks, whether it's a new dealership that has brand new trucks. Say, I really don't want to put a big kit permanently on this because I don't know if the end customer is going to buy it. But at the same time, too, is I don't want to keep jump starting it or having to run the engine because we went and visited several local dealerships, and salespeople go out there and have to start new trucks sitting on the lot, and to make sure they stay charged, to avoid lot rot. That's a lot of fuel being burned for no reason, a lot of wear and tear. The other thing, too, is when they get new trucks delivered, they never put a lot of fuel in them. So if it doesn't sell fairly quick, now you may have to take it and go put more fuel in. So that was designed as a temporary portable solution. Now, because of that, some have said, hey, that has worked so well, let's go ahead and put the big panels on permanently. But again, that was designed for new truck lots, trade trucks, things like that, where you can easily move them, unit to unit. That's again why it's got alligator clips or the cigarette lighter or eyelets. So depending upon what type of connection you want to do, we can hook it up, whatever, make it very, transportable or movable between vehicles. One thing is we kind of missed on the previous question too. I don't think we covered it, was the mounting. Is obviously the panels go up on the roof. What about the controller? That always needs, at least for our units, we want that controller in the battery box. We want to be able to read the ambient air temperature, what those batteries are subjected to, because one is we have temperature compensation. So if it's colder weather, we can raise the voltage up. If it's hot weather, we can lower the voltage. So we're getting the best charge in those batteries as possible. Plus the other thing is the controller is what sets that voltage. If you put it close to the solar panel, and then you have 20 foot of output leads, obviously you have voltage drop and all the other things. It's going to impact the solar panel's ability to charge those batteries. So we want it as close to the batteries and in that environment, so we know we're reading an accurate temperature for them too. Go back to our Q&A slide here. I see we had a couple of them. One was a question we had earlier, was for could solar charge electric power jacks? And yes, it could, and we've covered that. There's many different ways we can do that, and we'd be more than happy to reach out to you and talk to you directly about how we can do that. Different ways to do it. We do have fleets that are using solar to charge their pallet jacks a number of different ways. Another question. I'm going to let Cody handle this one, but the question is, how does snow and ice affect the panels? Output and damage from ice.
So snow and ice will affect the output. Anytime you cover those panels and you prevent sunlight getting through to them, they're going to have decreased output. That being said, we've not experienced, or we've not gotten reports from any of the fleets where we've done rooftop mounting, even in northern applications where those snow removers rake across the top of the trailer to pull all of that material off. We've not heard of damage coming from those applications, again, because the panels are affixed with very, very strong adhesive and sometimes rivets as well.
And the panel itself, with these flexible designs, maybe 1/8 of an inch, 3/16 of an inch thick. So the panel itself is very, very thin. The thickest part of it's probably right at 1 inch, where the connectors, the wires connect to the panel. So that's only, 2 little cubes, if you will, or boxes on the panels that stick up at any height at all.
And I'll note also that those cubes that Larry mentioned, where the cabling comes out, there's actually the output of the panel, are now on our newest generation of panels, all beveled. And so they do tend to deflect anything that would come up on them.
All right. And one thing is, please, nobody leave till we're done with questions, because we do have a survey for you at the end. So we'd like to make sure everyone stays on for that. Let's see if anyone else has any questions here. I see no more coming in. So with that, I believe we'll say thank you for joining us today. But again, please stay on for the survey questions afterwards. If you have any more questions, please don't hesitate to reach out to Cody or myself. Again, our contact information is in the resource folder there for you. Or most of you know our email addresses or whatever, reach out to us. I just had another question maybe pop in. And just question about, panels, for, universal applications. Yes, they are. Again, like I kind of showed you the first part, if it's a 12 volt or 24 volt, we have a solution to be able to charge those batteries. So, it doesn't matter if it's on a truck or a reefer, straight truck, standby power. We've got people in the oil rig industry that have used them for monitoring stations out in the middle of, West Texas. So there is a solar application. Now, some of them will try to be honest with you. Says, for what you're wanting to do, we'd have to cover the entire top of your trailer, with panels to be able to do what you're wanting to do. There's just not enough energy there. But we will always try to be honest with you and say, is this a solution or not a solution? Or maybe a combination of other things. Hey, it's going to take solar and product X or Y or whatever to do what you're trying to do with the power requirements. So with that, we will turn it over and thank you all for attending.